afternoon, ladies and gentlemen. It's a great pleasure to welcome you back to the afternoon sessions of Chip and Semiconductor in the COMPUTEX Forum. So in the afternoon sessions, there will be 5 outstanding speakers from the semiconductor industry to deliver their speeches. The first speaker, we are very honored to invite Mr. Samir Watson, VP and General Manager of Processor BU at Texas Instruments. Mr. Watson will talk about making the future of embedded possible. Ladies and gentlemen, please welcome Mr. Watson.
All right. Can you hear me? Okay. So good afternoon, everyone. My name is Samir Watson, and I'm honored to be here representing Texas Instruments. And starting this session, my esteemed colleagues will come in and add their thoughts. But the session here is mainly about how our industry is helping things become more intelligent and more affordable as we go forward. So let me start. The topic here for us today, at least from a TI perspective, is going to be what are we doing from an edge AI perspective to accelerate the adoption of edge AI and make it simpler and more adaptable across a variety of end equipments and electronics. So let's jump in. So this is a well-known fact. Modern electronics are driving demand for more integration and intelligence. So what does that mean? We all want our systems to be better in terms of intelligence, better in terms of capability. We want our coffee to taste better. We want our machines to be well connected. We want our systems to be safer. We want our packages to arrive sooner, on time, et cetera, et cetera, et cetera. And this week already, we've had a lot of discussion around how machine learning and AI is making that possible. That being said, to actually physically implement AI in real-world systems, you have to start thinking about the constraints which we put on systems, both in terms of cost, in terms of capability, in terms of power consumption, in terms of size, and that is where edge AI and embedded starts making a difference. When a system is developed grounds up or thinking about these constraints, the parameters you're working in from an AI perspective, from a capability perspective, change. You're no longer working in a server where power, while very critical, is still freely available. You're no longer working with unlimited space. You're starting to work from an industrial design perspective, from an aesthetic perspective, from a capability perspective, into something which is going to be sellable, which is scalable, and sometimes, more importantly, affordable. Building very exotic electronics, which is only catering to a very small segment of the world, is interesting, but not as interesting as building technology which actually scales and touches more people on the planet. So what makes TI unique in edge AI? And when I say word unique, I take it with a pinch of salt because many companies in edge AI are trying to do the similar things. From a TI perspective, we are trying to build our edge AI strategy on 3 key pillars. First pillar, we're going to build a scalable family of embedded processors. What I mean by that is we will have a family which is going to be entry-level performance, entry-level cost, and we're going to have the same family scale up to higher level of performance, higher level of capability. That's pillar number 1. Pillar number 2, we are not an edge AI accelerator. We are truly an application processor or a microcontroller where we are shipping into these applications today, and with the innovations we are trying to do, we will be able to make them intelligent by seamlessly transitioning from the existing generation to a new generation with AI capability. That's a very fundamental pillar, number 2. And the third one is we are investing in open source tools and software so that you don't, or our customers don't have to be AI experts. We're trying to bring the barrier of adoption on machine learning, on AI, significantly lower by having simple open source, almost no code AI aspects, which should enable a faster adoption of our technology. So again, 3 pillars. scalable family of AI processors, innovative processor families which allow AI capability into existing applications, and then combining with no-code to very low-code open source tools which allow the barrier of entry to adoption to be very, very low. So why does edge AI truly matters? And many people will come and give their own perspective on that. End of the day, AI which is far away from the actual application and from real world scenarios isn't going to be reliable, cost effective, capable to do decision making when decision making needs to be real time. Cost is critical, and while you can offload tasks to cloud, sometimes decision making needs to be real. If you're pressing a brake in an ADAS system, you are not going to wait for the system to go back through V2X, connect back to the cloud, make a decision, and send it back. You're pressing a brake based on local AI, local sensor data, and immediate decision making. And just looking at the example I just said, any vision application, so if you take a camera application 10 years back, and we've been shipping into cameras for a very long time. If you take a camera application 10 years back, you would record the incident and then play it back later. Today, same applications have enough technology to be able to not only record the incident, but actually activate alarms and sensors based on the situation, based on real-time tracking, real-time object identification, and real-time classification. So this is an example of why edge AI is fundamental to bringing AI into the mainstream of electronics as we go forward. So a few examples of where intelligence at the edge is needed. Automotive, it is the most intuitive, most commonplace example of edge AI implementation today. Whether it is in ADAS, through cameras, whether it is in ADAS through radars, LiDARs, whether it is through sensor fusion, that is fundamentally what we are seeing a lot. We are starting to see edge AI come into inside the cabin as humans interact with machines inside the cabin, how we benefit and we improve that experience. That's becoming more and more fundamental. A good example of this is No Child Left Behind. No Child Left Behind through radar sensor technology, through camera technology, through sensor fusion technology is starting to give capabilities to car manufacturers to build very affordable sensors which allow you to have technology which can detect kids left behind and does not lock the car, brings down the window, sends an alarm to the smartphone, et cetera, et cetera. Bring that over to driver monitoring systems. Driver monitoring systems which at one point used to be available only in very high-end vehicles are going to become commonplace because this is now more affordable. Some of the customers which we are working with are using these in standalone rear view mirrors. They're integrating it with their ADAS systems. It's becoming more and more mainstream. So automotive is a very good example of where edge AI is already starting to play a very fundamental role in how electronics is evolving. The next one, and not as well thought through or thought through yet, is industrial or medical. Again, industrial systems have been around for a long time, and they have a certain level of automation. But even today, the usage of edge AI in industrial is in a very, very early stage, very much in its infancy. And what that means is there's a long wait for us to go grow that. Capabilities of enhancing just robotic arms with smart cameras, pick and place, retail, warehouses, whether you're able to go have lights out warehouses over time where human intervention is lesser, you can make it safer, et cetera, et cetera, et cetera. These are very good examples of where industrial automation can play a key role. Medical, again, a lot of diagnostic and real-time capability with edge AI is just very much starting. And then the last one I will say is retail. Today, retail is still a market which is very underpenetrated from just an electronics perspective, but also from an edge AI perspective. Whether it is labeling, whether it is shelf management, whether it is inventory management, whether it is just robotics and warehousing, very, very, very early stage. So These are some examples where edge AI can play a very key role, but is in very, very early stage of its adoption. And again, our goal is to continue building technology, bringing that barrier of adoption lower so that it can permeate into some of these markets which have the need but don't have solutions yet. So earlier this year, we announced our first family of scalable vision processors. And this is our first foray into edge AI with a holistic approach of a family of processors which are catering to the vision application. Now, what we have done here is a few fundamental things as we've thought through different use cases, but also different users. First and foremost, defining a family of processors instead of one processor. Why we do that is our customers are spending a lot of their R&D into software. The speed at which our customers can develop their product is directly proportional to the amount of software variations they have to manage in their product development. By maintaining one architecture across the entry-level processor to the highest level processor, we are ensuring that the investment our customers do on software is conserved as they go out and build out their product portfolio. So that was our first and foremost criteria. Second criteria was to try and make this as simple to use as possible. What I mean by that is many of our customers are going to start using vision and camera for the first time in their application. It could be from a very simple coffee machine to something as advanced as a robotic arm. Bringing vision into the mainstream without them having to worry about ISP tuning, without having to worry about what model, et cetera, is a very fundamental design concept which we are trying to bring in as we bring this out. And then the last one is scalability. So there are solutions out there today which will do really well for one or two cameras. And then if someone needs to go above that, you're starting to go into the hundreds of dollars of processors which are not grounds up built for edge AI, which means they're not necessarily thinking about power, they're not thinking about safety, they're not thinking about how does this application embed in the overall application space. So we attacked these three things, and we came out with this family of processors early this year, which is the 6.2a, the 6.8a, and the 6.9a. And all of them have very similar characteristics. The 6.2a is an entry-level camera processor which supports 1 to 2 cameras. It can also support other sensors such as radar, LiDAR, but fundamentally very entry-level, very straightforward. 1 to 2 tops, integrated machine learning accelerator, has safety capability. Think of it as a DMS application, an auto application. Think of it as a smart camera application on a warehouse floor. Very, very entry level. We also announced 6.8a and 6.9a. This is up to 8 cameras, and then 6.9a is our top of the line, up to 12 cameras. And again, the key point here is scalability to the highest end. So now if you're a customer, say you're building robots for warehouses, you're going to look at a family of processors and decide, OK, I can start with 6.2a because I'm going to have some very, very simple camera applications on robotic arms, and I can scale all the way up to 12 cameras if I'm building a much more complex pick-and-place system, et cetera, et cetera, et cetera. Same processors for video surveillance, applications, warehousing, anywhere where you see a scalable need for cameras, and cameras are all around, but fundamentally to be able to do that on a single software stream, but also meet your performance requirements as you scale up in a cost-effective manner was the goal for this. Let's take an example of what 6.2a does from a retail store and factory perspective. So again, as we have thought through the workflow on what a customer would need to go develop in a retail environment or a warehouse perspective, the 6.2a has a lot of those building blocks which you need. First of all, it has an ISP subsystem. ISP is image sensor processor. Fundamentally, this used to be black magic at some point. There were very, very few players who would tune it. There would be very few players who would be able to go work with camera lenses in different lighting. If the lighting is anything like this, your lens would not work. These machines have to be fundamentally automated and be able to be deployed into multiple scenarios. How we make that possible is by having the simplest ISP tuning or pre-tuned lenses which you can find. We have tools now which will allow customers without any imaging background to be able to tune ISPs and come out with products in a seamless and time-efficient manner. Next, along with the ISP, we have our own vision accelerator pipe, which goes directly into our AI accelerator. Our AI accelerator is homegrown. It is based on TI DSP technology for many years, combined with dedicated matrix math multiplication, which we have now had for over 5 years in products. We have scaled that. We have scaled that from really small in the 6.2A to really large on 6.9A, but it is the same framework and the same piece of hardware. This is supported by all open source frameworks, Onyx, TensorFlow Lite, et cetera, et cetera, et cetera. So no longer do you have to program a TI DSP. You can keep your programming to standard frameworks, and our compilers and our translators take care of the rest. This then gets fed into our standard ARM Cortex CPU, and then can go out to a display or can go out to a decision-making entity. So fundamentally, in one SoC, this is not an AI accelerator. This is not only an application processor. In one SoC, we have combined the capability of camera processing, machine learning, and display processing to be able to give our customers the maximum amount of flexibility for the use cases, such as what we're showing here is a retail and factory example. Along with that, obviously, TI supports Linux. We also support Android, but Linux is a very fundamental strategy for us. We upstream it, we maintain it, and we provide kernel support for multiple years. Speaking of software, the other big investment from our perspective to kind of accelerate the adoption of AI in this space has been what we've done from a tools and software perspective. So this has been a journey for multiple years, and I think we are starting to come out with something which is very, very compelling for customers who are not experts. We are not expecting customers to come in and be experts on TI DSP. We are not expecting them to be experts on AI. We are trying to appeal and cater to the audience of our customers who are not experts in either and bring them into the fold to be able to bring this functionality into their products. So 4 key pillars for us in our software and tool strategy. First and foremost, we have just recently launched what we call the TI Developer Zone. And this is a combination of many tools, starting from very, very simple clock muxing tools all the way up to system configuration tools and GUI composer tools, et cetera, which allow customers to not have to pick up the 10,000-page TRMs and be able to go program on processors with very, very simple tools on that. Next, Edge AI Studio, and I'll have a slide coming up very shortly, is our open source platform to test AI models very, very quickly. We are also collaborating with some third-party AI models, but this is a first-party tool which the customers get directly from TI at no cost. So you can bring your own model, we can provide you the model, and you can go test which of these models work with what part of our solution and get real benchmarks versus artificial PowerPoint benchmarks. Next, the other 2 are very standard: software development kits and our Code Composer Studio, which support our AI development for our customers. This is a summary of what our no-code Edge AI development studio looks like. So fundamentally, this is a single point, single tool, which we have for customers to bring in their own models or use existing models to go optimize, to go figure out what piece of hardware is the most optimum. So you could use a 6.2A, a 6.8A, a 6.9A. You could benchmark how does your use case work on that. You could generate AI code, without having to actually write a single line of code yourself. The tool will do it for you. And all of this is available on TI for free of cost, completely. There are competitors and there are third parties who are charging a lot of money to our customers to be able to do this. We are providing this right out of TI, fully managed, fully supported, to, again, accelerate the adoption of Edge AI for our customers as we go forward. The other thing about this is, behind this tool is actually a virtual farm of EVMs, or evaluation modules, with actual hardware for our devices. So you do not have to rely on simulation. You don't have to rely on any paper benchmarks. You can actually run your code within minutes on actual hardware to see how it's performing and get true results without having to wait for the hardware to arrive to you, without having to order anything or to pay anything. So sitting at home or sitting at your work, you can go figure out whether your AI application is going to fit TI's hardware portfolio by using this tool without necessarily being an expert in AI. And like I said, the deployment at the edge, very standard, Onyx, Python, TensorFlow, TVM, and we are continuing to support even more open source frameworks as we go forward. Along with that, we also have a very large TI model zoo. So again, a lot of data, pre-annotated data is available for you to go test out your AI model and make sure that it is working for your application. So again, this is a big investment for us. It is something which we are doing to make sure that we are the best vendor when it comes to AI adoption at the edge and try and accelerate that. To summarize, between what we have done on the hardware, which is a scalable family of processors starting at the very entry level all the way up to a very high level, single software base, combining that with what we have done on Edge AI Studio, gives our customers the tools to get started, to bring your existing applications and insert machine learning capability into those applications. If done correctly, this can accelerate the capability for our customers to build intelligent products, intelligent electronics, and bring it to the mainstream. And reducing that barrier of adoption has been a key focus for us. With that, I'd like to thank everyone for their time. Appreciate everyone's listening, and look forward to getting your questions directly on TI.com, and as you start your development with the TI-based processors and tools. Thank you.
Thank you, Mr. Watson, for your inspiring speech. Please return back to your seat. Next, we are very honored to invite Mr. Maury Lin, VP IoT Embedded and Edge Computing at Supermicro. He will talk about redefined performance at the edge computing for AIoT and telecom open range modern workload optimizations. Ladies and gentlemen, please welcome Mr. Lin.
Good afternoon, everyone. My name is Maury. I feel good to be back here again. 4 years ago, I was here to talk about edge computing. But today, we can add a little bit more now with a higher performance and plus the AI part. And it's a great journey to help you to understand what Supermicro can contribute to this topic. But there are lots of the foundations topics that have been mentioned by TI, Samir. He mentioned to you about those kind of things at the edge. There are many kind of formats. But there must be some different roles Supermicro can help. So this is the topic I prepared for you today. It will be about when we were in Silicon Valley, how to do the innovation for you, and also how to drive those innovations from the data center to the edge, plus the AI's powers together. For sure, you will see some examples and how we did this together with our customers. Our company based in San Jose, which is our headquarters. And last year, we made 5.2 billion size. And now we target, in this case here, hope the 35% growth. In this case, the worldwide, we got 5,000 people, 50% are the engineering powers. And then we also have the $50 billion capacity to support our business. This is the foundations we create for the world. Because of this, there is a very, very hot and popular critical segment, which is the AI. And in that case, AI could be in the data center for machine learning, but the AI will be also help lots of things at the edge with the things together. And then there will be a role there, the virtualization and server will help a lot. So in this kind of a combinations, we got a chance to contribute to this ecosystems. You can recognize here, lots of people talk about NVIDIA's CEO Jensen mentioned about the iPhone moment. I just make it simple. It's just something, it's hard for you to imagine what's come to you, but eventually it will become part of your life. I think AI will soon become like this. Now it's hard to imagine, but soon you never ask yourself why you need an iPhone or a smartphone. Now the AI is going to be from the data centers all the way to the edge to help all kind of industries. In this case here, there are a few things that give you some good idea, like the generative ChatGPT part. And also those kind of high-end computing inside the data center, they also expecting collect more data from the field, which is the edge is going to give them more chance to study, to train the machine, and to learn. Because of this, I think you can see lots of the different consulting company have a different understanding about how they calculate the data measurements and how we process the data together. So inferencing is one of the case AI can help at the edge side. So we will give you some ideas of how to bring the inferencing powers to the edge to work together with those Internet of Things, which is the AIoT as well. This is the spectrums. We're starting from the top like a cloud, but it's not just the cloud structures. Data center will give you the chance to bring the highest computings all the way moving to the central location for your data storage and push further to the customer premises equipment. In this spectrum here, you can recognize there are lots of different kind of vertical markets could be focused. But the key is what is the edge computings? From our understanding from Gartner's reports, when the data generated, collected, and processed, the location we can call it as the edge. And there are lots of things happening there. So we can also recognize it's a sub-market. So we have a role there to work together with those things connected at the edge. And that means you need the computing performance. You need to have a fast storage, and also need to have AI power when the data become a huge packet. Because of this, we are ready for you to have some structures changed, transformed into the form factor at the edge. First of all, it's hard for you because I believe most of people are not the person working in a data center. But you can recognize it's just like a cabinet with a tall size like a drawer. You can put many high-performance server into it. And which is the case like a ChatGPT machine will be installed, a form factor like this, a cabinet. That will be in the data center, high densities. But what about those things are not in the data center, still need AI power? Then you will need certain kind of different form factors, including the way you want to install your machine, including the different challenge like temperatures, and also the form factors. You need to get it smaller, no longer just like a typical rack mount machines. So luckily, we got two different approach for you from the data center side, and also can be starting at the edge, and all connected together. I bring the four factors to share with you to look at what happens at the field. First, those kind of area have a compact space requirement. Then you will need to create a machine able to work in those conditions. That means your machine no longer could be on the table. It got to be on the wall or somewhere else. In that case, we have some way to solve the problem. Second part, in the food services we have every day, they also have IT device around them. With those greasy air and the dust, the machine itself will suffer lots of challenge to their cooling solution, like through a traditional fan. If there's too much process there, it will be a big challenge to the system, won't be stable anymore. So we also have a fanless design to bring the server performance. Also, the coming one about the expandabilities. As you can see here, workload is all different. You have some shop, they might be 100 users, but you also have a space, like right now, we host 400 people here. The workload is different. So at that time, at the edge, you need to customize your hardware to support those kind of workload. And the last one here for sure is the most popular topic now, which is the AI. And AI could be in the data center, but at the edge, It's very important. You need to have enough customizations. You cannot just keep pushing the data center power to the edge. It's too much and too high cost for the edge user. So it got to be some form factor to support them. Therefore, here we go. We got a different kind of form factors machines to support the ideas. Starting from the ground here, you can see different kind of format. The format could be the general rack mount with a high performance front access for everything, but a machine also could be like a pole mount device. It's very powerful. And all the way to the left-hand side become a palm-sized box without fan. Could be all at the edge side. And there are 3 factors we can share with you what we found from the industry. First of all, the form factor need to be diversified enough to support all different kind of workload requirements. That means if they need server performance, we have to give them. But if also they want to certain middle level workload, we need to offer that box as well together. The middle blocks here, we want to let you know, at this moment right now, lots of the different accelerators come to the world, including the GPU. And they also bring the big challenge to the systems because you know they are very power hungry and form factor is pretty huge. So when you put it into the small box, as the providers, we have to make it reliable for you. And we know how to do that. The last one will be on the top, how to put those niche features into the edge system design. We have to consider the space is a concern. Everything got to be easily friendly for operators to do the service, so front access. Those kind of things, it's tiny things, but it's also make you different, make the customer, the pain point could be solved. Because of this, I want to give you some idea from the hardware perspective, and later on I will show you from the decision maker perspective how they select the different hardware. In this case here, you can recognize I mentioned to you from the data center to the edge, there are different form factors. Then product could be like a rack mount cabinet, all the way to the different form factors, multi-node, density is pretty high. Those kind of things will give you the chance to keep all the computing at the one location, but it's not enough when you have thousands and thousands of locations. So you need to have a different distributed structures for the edge computing and also centralized structures to do your critical data control and the machine learnings. And for sure, because of this, you can recognize 5G and other telecom bring the new chance to this edge computing. They solve the bandwidth and latency challenge. So which is the reason why I use this spectrum to give you the short ideas. Now moving to the next slide here, it's switch the role right now. At this space here, if you are the decision maker at the edge, like a store managers or production site manager, your questions to yourself is not how to select the hardware, it's how to reduce your cost of the operation and also have the efficiency of the productivities. Because of this, you have a certain process need to go. Have to identify the problems and also need to find how to make this a proof of concept could be tested and then become a product could be deployed. Because of this, we cannot be just alone to offer this to the industry. So there are certain partners will be invited, including consultants, independent software value providers. Those people are the critical roles in the edge computing. So we have to work together. I will give you one example. In the case here, we have edge computing requirement. The customers are expecting the computer visioning will help the retail business for the self-checkout. At that case, you know you have lots of choices. You can using the entry-level AI. But why this is the case I want to share with you. They are expecting to have the chance, when you finish the checkout process, you don't have to scan the barcode anymore. They prefer just put it on the table, and they can recognize what is the goods. Doing this job using your eyes through the cashier, it's very simple. But if you force the machine to do the job for you, like an AI, first, your data need to be labeled properly. And second, you have to process quickly. And when you have a multiple object together, they have to identify the right object, including a different light. Those kind of things will make you change the concept about those objects they identify. So your camera need to be fast enough to identify the object. Because of this, you find you need to give them enough performance. The second thing is they are not going to give each machine have one server there. It will be too much budgets to one location. So the virtualization will also help them to support different devices. The one, to our understanding, they can support up to 4 to 16 cashier checkout self-service. So they can using typically the high-end GPU power into edge computing to support this virtualization service. So from this angle, you recognize customers no longer, they just ask you to give them the hardware. They have to figure out these ingredients by themselves with our support. Because of this is a box how it looks like. It's allow you to put the different kind of accelerators into it. And this will help you to solve the different location challenge. Because this machine itself can be mounted to the wall. And also can be put into the product, become an outdoor edge device. And the bottom part here, I show you the different accelerator choices. You can have it from NVIDIA with all different inferencing power, and also from Intel as well. This kind of accelerators allow you to bring the AI to the edge. And with this kind of format, you are also able to collect all the data efficiently. Because of this, we would like to put it into the form factor more friendly to the edge computings. So that's how we call the AI in a box. I give you some examples. In the retail space, we do have a requirement from the customer. They're expecting the edge AI need to have the chance to make their environment easily for the data collection, traffic control, inventory analysis, and also try to see where those areas they can solve the queuing in the line problems. Those things that they use lots of the big data to the analysis in the past in the cloud. But when they start to push the high definition data back to the cloud, it's created a big cost. So they need to find a problem how to solve locally before push everything back to the cloud. And when you collect more data, you want to have a quick data result through the data mining. AI is one of the answers. That's why the parallel, this kind of calculation, will easily for you to do the data mining parts. And because of this, you need to have the machines stay close with them instead of put all the workload in the cloud. So edge AI in the format is similar concept from the data center, but make it a small, compact form factors. This is one of the product lines I want to share with you how it looks like. It's a palm-sized machine without fan, and all the way to the two-hand size. The things here, it's a server inside. And normally the server, if you remember, I told you they put in a cabinet. It's a tall one, but now we bring those computing power into the small box device without fan. So those areas I mentioned to you have a greasy air challenged, no longer is an issue anymore, and still have a very high performance. And how it looks like is the product like this. The case is very straightforward. Those kind of computings will give you different workload. And if you have cameras up to 64 cameras, you might need a very high performance one. But if you just need to handle 4 to 16 cameras for small shops, you're probably looking for a small device like the palm size here, also fanless. So we are able to do this for your different workload configurations. And because of this, it's making it easier for you to do the cost down part. I'll give you another case here. You see the robotics arms and also other thing in the production site. To do this case in the Industry 4.0 here, we recognize the robotics arms actually itself already have a good chipset inside. We are talking about those cameras around help those robotics arms to move. And also to make sure when the people walk into the cold zone, the hot zone, that means that there was a red line you cross, robotic arm have to stop right away in case of the casualties they hit you. So those things, the camera itself doesn't attach to the robot arms. It's actually around those areas. Because of this, you need to give them the inferencing power to detect the object. It's an authorized worker or just an accidental visitors. So this is all require lots of the AI at the edge for you to drive. And not just about that, there are also lots of the data aggregations in the Industry 4.0 case. And for you to collect the data to make sure your production capacities could be improved properly. There's also another case with the AI power at the edge, smart city. We all came here today with the typhoon days. You can recognize the camera probably collect lots of data with a rain shape. And then those license plates recognitions, those object detection have a new challenge. Can you still keep your city safe? Then the key is with the AI power inside because they have to eliminate those factors, rainy days, dark nights, and also with the typhoon attack. At that time, you still need to make sure the camera will protect the citizens, right? So in this case, you need to have a high performance enough device, not just rely on everything in the cloud. So Supermicro, at this case, we have the machine can mount it to the pole and then still carry the different GPU inside I put a car there to show you. It's how the car looks like. And then it will be able to wire out, connect all the outdoor cameras together. When this whole set together, next time you're on the street, you pay attention to things next to those traffic lights. It's actually all the concept like this. But now you probably will ask us, hey, I saw it every day already. What's the difference? The difference is about if you want to collect more, if you want to eliminate those noise, then you need to have AI power, inferencing power at the edge. That's the difference. So that's the reason why this demand is going to help you a lot to monitoring the environments and also make those areas become safer. You can recognize here, I put the different scenario in the stadiums, airports, homeland security. This is one angle, but you can think about it as a border control. So it will allow you to detect lots of things. And you need to have a computer visioning to do this job. For sure, I also want to bring you the last case here. Energy sector here. The wind farms been there for a while. Taiwan has a lot of wind farms around us here, not just in Taiwan, in Europe, in US as well. It's a clean energy. And then what's related to the AI and also the supermicro role here. Those wind turbines, every time they are spinning, they will create different kind of a sound patterns. When the sound patterns is not right, that's just like your fan at home. You can recognize that something goes wrong. But you cannot send the people living there 24/7 just detect the sound, right? So you need to have some small device do other job instead of interrupt those energy collections. So as a palm-sized fanless machines allow you to collect those kind of different challenge to those wind farms blade. And because of this, once you gather all the data together, the AI is coming into this segment here to make sure it's how you can collect the right way to put the more wind farms, to detect the wind directions, to define the hill, to find out the place to put more density to collect the highest density for the energies. Those will have the big data all connected together, but you need the AI to continue to tell you those areas are the right place to invest or not. And we are the role here. We give them the one of the box to do the job. Telco case here is one of the subtopic here I want to share with you all. I prepared one slide, not too many. It's a tough topic, but it's interesting for you to change the concept. Why the telco relate Edge AI? First of all, telco help you to, telco markets, actually you have your phone every day. It doesn't change your life, but why it matters to all of us here, because there is openness happening now. It's called the Open Radio Access Network. It's allow us to contribute using the general purpose hardware to work together into the mobile network. And to make this possible, there are lots of the building block solutions Supermicro provided to the industry. And then one of the customers' testimony here, the customer from Japan, Rakuten Symphony, they use our solutions to drive this open RAN to help the world, to make this radio access network become open to lots of the infrastructures. And then what's the value they brought to you? It will make you easily to access with a lower cost. And then also bring the 5G with a lower latency. All these big values actually will make the Edge AI with those high data processing at the edge possible, affordable. So it's an infrastructure change. So when you look at this Edge AI, it's not just about the computing. It's also around them how to make these infrastructures become friendly and able to push the contents together. I would like to give you a deeper in after you have a network built in your environment, then why you still want to think about the private network? I got a public network already. Then what's the purpose to think about the private network? So the private 5G is a very critical topic around the world right now. It's allow all the different enterprise to do the way they want to keep the data local in their locations. And second things, they want to make sure those network will be stable enough and quickly could be built within a short time frame and the high mobilities when they have to move the stations instead of just like telco towers. You'll be there for decades. You cannot change the towers, right? So in this portable concept here, we find this values is huge because it just kind of you bring the flexibilities to the enterprise customers, allow them to control the network settings by themselves. Because of this, you need to have a small enough device, portable, easily to be deployed. So the machine, just like a suitcase, you check in the airplanes. And there will be 3 server or 2 server inside, and plus a radio unit on the top. That radio unit will allow you to control different kind of, they call the video realities, the virtual reality, the VR goggle. So why is the values to those segments? I bring you some cases here. In this case here, because you have enough intelligence at the edge, so this virtual reality will help you to interact with those contents. You have to do the trainings. You have to do the quick modelings. So those require the GPU and AI there to train those data pushed together. But a private 5G network will make it easy for you to deploy at that case. And because of this, we have the partner here from HTC called G-Rings. They do have a live demos in the whole one. And it will give you the feeling how you do the modeling. You touch a card, and you open and see the texture inside. And why it matters to the car industry, because it can save their cost before they modeling many things for sample reviews. And this is all the values we brought to here. And you cannot miss the AI powers to drive those GPU calculations. So I think all this kind of a summary together will give you a feeling. When you look at the previous concept from the TI mentioned about the chipset put into the camera to your coffee machines, and then you need to have servers to collect those data. And the GPU will enter to make those data become meaningful for you. And then the private 5G network will give you the flexibility, keep the data locally, or you use the Open RAN for the affordable networks with the 5G performance. All this story connected together, which is the reason why it looks like Edge AI topic very straightforward, but you have to handle many things all together. And luckily, Supermicro can contribute a lot. I think the case here, from our perspective, accelerate everything sounds very exciting, but also bring the very critical responsibility to everybody. You can accelerate, yes, but is that secure enough? So you need to have a lot of devices to make sure your data is correct. And the second thing is sustainability. When you have so much power-hungry GPU running around the world, we can contribute something to make sure your machine green enough, and then can keep the same performance and still have the energy efficiency there. Because of this is our missions. Supermicro would like to do this way, offer you the best products from the cloud computing, edge computing, to the telco space here, all with good concepts inside, and then to bring you the edge computing and AI plus together. I think I want to thank you all for participating in this session with me here. It's a warm-up session for you to understand the edge AI power for the whole industry, not just for Supermicro. But we also want to clearly to let you know how to align the message you want to share with you. So tomorrow, our CEO, Charles Liang, will present his CEO keynote session. We got a very special guest. As you all know, Jensen will be there with us. And they will share their journey together. And they will talk about not just the topic I mentioned about edge AI. You can imagine now it's everywhere, right? Accelerate everything. So there will be lots of the critical topic will be addressed tomorrow. And I can see you all tomorrow. Thank you.
Thank you, Mr. Lin, for your inspiring speech. Please return back to your seat. Next, we are honored to invite Mr. Avi Shetty, Senior Director of Strategic Planning and Marketing at Solidigm, to talk about storage innovation is the key to solving tomorrow's IT challenges. Ladies and gentlemen, please welcome Mr. Shetty.
Good afternoon to all and good day to everyone watching online, and welcome to COMPUTEX 2023, one of the biggest technology events, and I'm great to be back here and great to meet all of you again. As we all know, the world is generating more and more data ever before, and it's imperative that we have the right storage solutions to manage and process this data efficiently. I hope you will find this presentation today from me informative, engaging, and thought-provoking.
Solidigm.
I'd like to frame a discussion of a modern PC experience with a quote from 1984. Donald Knuth is known as the father of analysis of algorithms. In many ways, his comment is true as it was nearly 40 years ago, but that's beginning to change. You're hearing all of that today from our fellow presenters. Self-driving cars, ChatGPT, IBM's Watson beating game show champions on live TV. There are more and more examples of computers thinking like humans, anticipating their actions, solving their real-world problems. Yet, day after day, many of you sit, me included, in front of a PC that sees the world the same way it did back in the 80s. User, all of us, manually enter the requests, storage devices fetches that request, our CPU processes it, and then again we go into that same cycle of rinse and repeat. What if we could apply some intelligence to that process to reduce or eliminate the time you spend waiting for your PC to respond to your requests? And that's what engineers at Solidigm are hard at work on today. Hardware and firmware innovations can get you pretty close to a responsive PC experience. But storage software, which is the crux of my presentation today, closes that gap. On the left is a situation as PC users have known it ever since. As you can see, there is no system intelligence. The system is just waiting, and the user is waiting for the data to get processed. It's purely responding to users' input as it is received. Now, if you have an SSD, you have to wait less. But if you have a hard drive, you're waiting a lot more. On the right is a different view where we are headed. Imagine a world in which you sit down in your office PC at the beginning of the day, and the system recognizes you. It automatically starts all the activities which you pre-planned for, loading your web browser, loading your email client, pre-caching your project file so that it's available and accessible to you right at the start. Or maybe streaming music applications, or maybe if you're into Sudoku, get your mind right before you get into the work, it can do it for you before you sit down on your PC. And that's where Solidigm Synergy comes into play. We are investing in a software solution which helps eliminate all the user wait by prefetching and analyzing all the inputs and the user behavior so the user has to wait less. Imagine a scenario where you're a gamer and you're stuck behind loading screens. You've already went through games level 1 and level 2. So the system should automatically recognize that, hey, I need to prefetch level 3 and level 4. This is the future that reduces load times because the system knows you, knows your unique behavior, and proactively fetches files, pieces, before you ask based on your typical workflow. This future is not a remote possibility. It is here today with the advent of Solidigm Synergy software, and the experience will only get better with time. Now, before I go ahead and talk into software story and the benefits of software, a bit about who we are. As many of you know by now, Solidigm was born in December 2021 when Intel completed its sale of the NAND memory business to SK Hynix. The combination of heritage and from two strong companies created a unique competitive advantage for us with access to IP, technologies, and manufacturing capabilities of both. We are headquartered in California. Solidigm offers a leadership NAND SSD portfolio across enterprise, cloud, and PC solutions. We are a global organization with 4 NAND manufacturing factories that deliver a robust roadmap of products focused on pace-setting technology, innovation, quality, and reliability. We are a new company, but our legacy and history spans decades. Today, Solidigm's PC SSD portfolio is composed of products under both the Intel and Solidigm brands. We carried over the Intel 670p SSD, widely reviewed as one of the best value SSDs in the Gen 3 family, and added into it a second half of last year with Solidigm P41 Plus, our first Gen 4 DRAM-less PCIe SSD, and also our most recent offering, flagship Gen 4 saturating P44 Pro. Combined with SK Hynix, we represent world's #2 SSD supplier, and number 3 SSD vendor by market size. Okay, that's about Solidigm, but now let's go back to the question at hand. How do you build a smarter PC experience, one that anticipates your unique needs and optimizes it for them? It starts with understanding on a deep level what is happening under your hood. What is the workload? Who are the users? What kind of workload does those users generally go through? Let's look at 3 users here: a gamer, an office worker, and a creator. Each of them have a specific set of activities they routinely do, and each of the set of activities imposes a specific demand on the storage device. You might be tempted to think, well, the best SSD or the best storage device for me is the biggest number or the highest number on the retail box, typically in megabytes per second. But that's not necessarily true. Or more specifically, that's not the whole story at all. The number on the box is useful. It can tell you what the drive's theoretical max speed is, but it's not the sole basis for your purchasing decision. You are missing some key considerations. It's like buying a car based on theoretical max speed. The one data point definitely tells you something, but what about handling? Can it readily change lanes? What about acceleration? What about braking? What about fuel economy? I have twin daughters. I care about safety. I want car seats. But if I just look at the retail number and I buy a purchasing decision, what you would do is come up to a different conclusion. We have extensively studied real-world PC usages at Solidigm, and it turns out the SSD's max speed is not always useful for predicting end-user experience. So what kind of performance do you really matter, and what kind of performance should you look for when purchasing a PC or a storage device? It's mostly three things. It's either you're reading or writing, then you're looking at read-write speeds, whether the data is available in nice contiguous chunks or scattered in small places all across the drive. We in the storage world call it either sequential activity or random activity, or something called queue depth, which is a measure of how many transfer requests are pending at one particular instance of time. Using that framework, we can identify where the number on the box falls on this chart. Is it a high queue depth sequential read? How sequential or random read word activities really depends on the individual's workload. But we do see some trends. In the examples of the 3 users I talked about, productivity and casual PC user typically tend to be highly random in nature. By contrast, gaming workloads are more sequential. They involve moving around large data sets in the form of models, textures, and audio files. Content creation, on the other hand, runs the gamut. They span across sequential as well as random activities. But queue depth, on the other hand, is strikingly consistent in the real world. The average queue depth of a PC rarely exceeds 4. It's often around 1, meaning there is no queue forming much of the time. The system processes I/O requests just as quickly as they come in. The upshot here is, if you want to choose the best storage device for your PC, you want to be smart to consider performance at low queue depth and more emphasis on random performance. SSD vendors, on the other hand, the number on the box is somewhere far beyond what a typical user would encounter. SSD vendors report this number because it approaches the theoretical max, and higher the number means better is what the perception is. But what we see in the real world for the 3 users identified earlier is a completely different story. I've been kind here to put that number on the box in this chart. In reality, it's more like outside the box. It's entirely for dramatic. The reality is probably it's somewhere out. The point being, when you look for real-world activities, the numbers and the performances are different than what's shown on the retail box, which is one particular measurement. So we at Solidigm have tracing is something, you start a workload, you end a workload, and it gives you all kinds of telemetry information of that particular workload. We at Solidigm have accessed and traced numerous client workloads in the areas of gaming, content creation, productivity, commercial user, and typical end user. And in this scenario, and it kind of dumps a lot of storage jargon, but in this example, we are doing a simple Adobe Acrobat launch and loading PDF. This workload took around 9 seconds and moved around 300 odd megabytes of data. There's a lot going on here, but I want to draw you to the 3 metrics which I just talked to you about. Number 1, read-write mix. In this case, 88% of the activity was in the form of reads. It makes sense when you're just launching an application and essentially loading a PDF. Second, sequential versus random. As with many productivity workloads, this is overwhelmingly random in nature. 85% of this workload was random, meaning small chunks of data are being accessed from all over your SSD. And third, queue depth. The mean here is 2.1, which is typical for most real-world PC activities across the client segment. So that's a great example of a workload that does not benefit from the huge front-of-the-box number, which is typically a high queue depth, sequential read. Zooming out across a variety of workloads we've studied, here's what we see. The best thing you can do to improve the user experience for a workload is optimizing your firmware, optimizing your hardware for low queue depth, random, and mixed read and write improvements. Now that we understand the different vectors of storage performance, we are prepared to talk about how Solidigm's Synergy software is uniquely positioned to improve performance beyond what I'm showing here, whereas performance where it matters most. As an industry, we've been doing great in terms of innovation. From the hardware side, we've moved from SATA-based SSDs to PCIe Gen 3, Gen 4, Gen 5 SSD. From a NAND memory media standpoint, back in the day, we started in SLC, single-level cell. We moved to multi-level cell, tertiary level cell, and now we are in the world of quad-level cell, QLC SSDs. But what you see along with that, there is firmware innovations which have happened with new NVMe features, non-volatile memory interface features being added every generation. Simply, just innovating on hardware and firmware is not enough. We are missing a key piece of the puzzle. The software layer works great with hardware to unlock exciting possibilities that simply aren't possible without it. The coordination of these 3 levels of innovation is what will pave the way to a smarter future in which one's PC anticipates all your needs, optimizes, and delivers the data before you ask for it. That's the driving force behind Solidigm's philosophy, where we've launched Solidigm Synergy software, which we launched last year and just released a major update earlier this month. It's available for free on our website. Synergy combines 2 things: a driver, which introduces under-the-hood optimizations to seamlessly and automatically optimize your PC's user experience based on your specific usage patterns. It will optimize, one software will optimize the 3 different users which we talked about. If you are a gamer, your system will automatically optimize for your gaming workloads and your gaming usages. If you're a productive corporate user, it'll optimize itself towards that usage. We also introduced a toolkit which provides a robust set of drive health and status reporting features, as well as some useful functions like which everyone uses: diagnostic scan, secure erase. By the way, the toolkit is available for everyone to use. It not only supports Solidigm's SSD, but it also supports every SSD there is. We believe that this is the right approach to take, and the combination of hardware and software can deliver a better user experience than ever, even the best of hardware alone can provide. Let's see the software in action. Here we have results from 2 identical systems using the same hardware. The only difference between them is the addition of the software Synergy, which is on the right. This test is particularly run on our own P41 SSD, And the test scenario which we've used here is the one I talked about previously. It's low Q depth, it's random, and it's mixed read and write. What we are seeing here in the speedometer on both machines is the software is more than doubling the performance on the same hardware, even when the drive is 50% full. And that's an improvement of over 100% that is available to the user for free. As a wise man once said, the proof is in the pudding in its eating. I was talking to a few colleagues of mine yesterday in Taiwan. The proof of the dumpling is when you eat it. And it's the same example here. Here are for us, does the Synergy software work? The proof is in the numbers which we are showing here. Here are concrete examples of storage software can improve user experience on already excellent hardware. These are meaningful workloads that you and I deal with every day. Boot time, everyone does PC launches. Application launches, everyone loads multiple application launches per day. And with the software, you're getting 14% additional performance advantage. The third example, performance consistency, is something which I'm very passionate about and extremely important. Everyone knows when you first bought your PC, it was fresh, snappy, everything was quick, but as you start using your PC, you filled up your drive, you loaded a lot more applications, your drive became full. And after maybe a year or two, you felt the inevitable slowdown. That's because the system is not intelligent. What we are now doing with the Synergy software is we are able to cache all the frequently used files which the user uses, even if the drive is 50%, 75% full. As a result, give 120% improvement compared to the same hardware. To Mr. Knut's point earlier, it might not be exactly mind reading, but it might be the next best thing. And finally, PC Mark 10 in the client storage world, PC Mark 10 is considered one of our widely used benchmarks. And the reason is it uses real world workloads. Here too, we see a significant performance advantage in line with some generational hardware changes which we've seen in the past. The difference here is you're using the same hardware we launched last year. You are getting more out of it because of the software. Don't just take our word for it. Here's how the industry has reacted. Let's take a look. This reviewer's results were even better than our own. He reported an 8.5% PC Mark 10 improvement, along with a 7% improvement on 3D Mark storage scores. He says, Solidigm Synergy 2.0 is easily the best supporting software for solid-state storage we've experienced to date. This reviewer welcomed Solidigm's strategy to deliver value-added software features freely to our end customers. This is my favorite. It's simple, it's concise. This reviewer said, it's genuinely very good, it's shockingly good. It's nice to hear the positive things from the press, and it gives us acknowledgement for the work put behind it. But if you leave here today thinking that a software release is worth a look, that's great, but that's not the main point. The main point here is the future of PC user experience, the one in which your system adapts to your unique needs and optimizes ahead of the things you would do, is upon us. And it's not possible to fully realize that future with hardware alone. Only by integrating all the product layers you see here, we can revolutionize the way we think things are done. What we show here is the host device, the hardware, the firmware, the OS, and the application, all working together for bringing end-user responsiveness to the end user. That's the Solidigm commitment. We are just getting started in software. Along with having a leadership hardware roadmap, we have a long-term strategy roadmap here for software that just gets better, richer, with new releases every year. What we've shared with you today is just the start. While we are excited about innovations in our current gen software, there is much more to come. Now that we've untethered storage hardware from the conventional reactive role it has always played, sending it towards a future where it predicts your needs and optimizes your data before you even ask for it, the potential is vast. Here are just a few examples our storage software team, our architecture team are exploring and pathfinding for future releases. By leveraging AI, to build PC experience, AI-based hinting, storage analytics, telemetry-based SSD health monitoring, machine learning-based adaptive data management, user-based performance tuning. The list is long, and we're just getting started. Hardware and firmware innovations can tell and have been steadily improving PC storage performances for years. They will continue to do so. But to break out of the cycle of evolution and get into the territory of revolution, it takes willingness to challenge the status quo and to make investments that others are not. That's the driving philosophy for Solidigm. We hope you'll take this journey with us. Please stop by our booth or visit our website for more information. And thank you for the opportunity. It's an honor to represent Solidigm, and wishing you all the best and a great rest of the show here at COMPUTEX 2023. Thank you.
Thank you, Mr. Shetty, for your inspiring speech. Please return back to your seat. And next, we are very honored to invite Mr. Ali Osman Urs, Director, AI/ML Strategy and Technology, Secure Connecting Edge at NXP, to talk about advancing the state-of-the-art in ML security. Ladies and gentlemen, please welcome Mr. Osman Urs.
Thank you. I hope my audio is good. My esteemed colleagues have given quite an interesting background. I'm going to do a bit of a maybe slightly different approach, do a bit of a history and nostalgia tour throughout the presentation, but really try to bring in a bit of what is NXP Semiconductor's DNA. In our DNA, we do have a lot of safety, a lot of connectivity, and of course security is a fundamental component of everything that we build in terms of our general purpose processors across microcontrollers all the way up to our most capable apps processors. So we are observing an extreme acceleration in the way AI-based applications are adopted. It took about 75 years when I talk about history and nostalgia, like regular landlines, regular what's called plain old telephone systems. That took about 75 years before it reached 100 million users globally. Mobile phones sped up quite a bit, dropping to around 18 years before they had 1 million users. Applications like TikTok, 9 months to get to 100 million users. But you're seeing with ChatGPT, which is a large language model, a foundational model from OpenAI, it achieved that same milestone within 2 months. So we're seeing this huge acceleration in the adoption of AI-based technologies, solutions, and of course that creates a lot of opportunities, but also potential threats around the security component of it. But this talk isn't about ChatGPT, at least not too much about it. What it is really about is 75 billion smart connected devices. That is the opportunity that's out there. So these are true edge devices. When we talk about true edge, it's about devices that are anticipating and automating, and it's a very large opportunity to, for us, of course, as NXP as an edge device vendor, to get more of our products into the market. It represents the fundamental necessity of keeping the ever-increasing AI workloads these devices run secure as well. That 75 billion opportunity means that why do we have that opportunity there on the edge? Like, why are people trying to move into the edge versus the cloud, where current ChatGPT-like solutions are running purely on the server side, on the cloud side of things? This is about the fundamentals of the benefits around moving to the edge. The more you can do on the edge, you might be able to actually enable the real-time analytics. That's where you're collecting the data, so your response time is shortest if you're actually able to process that data and provide an intelligent response to the system there. You're not incurring the whole latency of moving your data off onto a server, onto the cloud, processing it, coming up with an instruction, and feeding that back to the edge device to take actions. So the latency, the ability to run in real time, which is fundamental to certain applications like automotive, et cetera, is critical. Then you also have costs of this network, of the infrastructure of a network. By doing more and more on the edge, you're able to reduce your costs and your infrastructure related outlay as well. You only transmit and process the fundamental pieces that you need on the cloud side. Most of your workload can remain on the edge. Essentially, another main benefit is that you're able to maintain proprietary private data on the edge. You're not creating an additional surface of attack by shipping it off, by having a communication channel in between and another device on the cloud server side that has to process it. You are transmitting only semantic data if you have to transmit at all, and that increases your level of privacy. And it also increases your level of security. So you're resilient to a lot of online and offline conditions through this. What do you need to build this edge ML solution? So some of the building block items are around edge compute. You have your fundamental device. So this is, for NXP's perspective, it's a highly scalable platforms from microcontrollers to apps processors, as I mentioned. They can be deployed in different applications with different space and power constraints that enable decision making at the edge. You have end-to-end security, which is required to protect your data and assets from external attack, as well as anything that's connected to allow collaboration across and between multiple sites. Then you have real-time communications, another fundamental part of our DNA at NXP. You're separating operational technologies that need the real-time control on the edge from also still allowing larger data sets to be exchanged between machines on the cloud side. We don't take an edge-only approach at NXP. We see the huge benefit of actually having more of a hybrid approach where you can have your cloud-connected edge devices. You do what's needed, most of what's needed on the edge, but still leverage higher compute, higher storage on the cloud side as needed. And of course, all of this comes together with machine learning. You need to have an ability to run on the edge intelligently. You need intelligence on the edge. And this is seen in our products when we start adding more and more dedicated acceleration for machine learning. What we've done is, in a lot of our product portfolio, especially newer devices coming out, complementing the CPU for general processing, complementing the GPU for graphics, complementing the DSP for audio processing, for example, we now have NPUs, so neural processing units, that are for dedicated embedded machine learning acceleration. And we enable that across the board. Of course, we still enable the other compute engines that we have also for running ML at varying levels of efficiency. So why are we doing this? What is the value that ML actually brings to the table? With machine learning, you're able to actually detect a lot of the trends and patterns, and you're able to automate processes. There is a lot of multidimensional complex data that ML and AI can handle a lot better than traditional methods. And you're able to do things like anomaly detection when you're talking about industrial applications, for example. So this all leads to enhanced predictive maintenance. You're leading into real-time decision making, as I mentioned, because you're more on the edge. You're not having a latency hit from going to the cloud. You have behavioral prediction, smart recommendations coming out. Overall, the fundamental value is also that you have increased security and operational efficiency through ML and AI on the edge. Why are we doing all that? It is a huge investment to make that happen. We saw the 75 billion devices expected by 2030, very large opportunity, but there's also an ongoing very large investment to achieve this and make this a reality. It takes a very great effort to create, train, and innovate on algorithms, the data sets, the models themselves. The overall worldwide spending on AI-centric systems is forecast to reach about 150 billion in 2023, slightly above that. And the annual growth rate is projected to be around 27% annually. So you're constantly spending more to build out these systems. Of course, these numbers include not just the software or just the hardware, but also the services around it. So it's the whole ecosystem spend and investment that we're putting into these solutions. And with all of that investment, you have to be careful that you're securing it, you're protecting your investment. These edge systems are under threat. For example, in the manufacturing space, about 23% of ransomware attacks were on manufacturing last year. And this is getting, with AI, with ML, you're actually increasing the surfaces as well. So this is mostly for brownfield deployments, older technologies. They have more susceptibility, vulnerabilities, but you're also seeing it as a very large lucrative environment to attack these systems. So security is fundamental to try to protect that large investment that you're putting in at 150 billion, growing 27% annually. So how do we do this, though? How do you protect that investment? Where do you protect it? What are your services? When we're talking about security for machine learning, especially on edge AI, on edge computing devices, you'll always have to account for what is it that you're doing. You're accounting for the data, and this is not just data at runtime or data you're collecting from your sensors. This is data that you've already collected and you're leveraging for training. You're leveraging this data for your training prior to runtime. You're leveraging the data that you have at runtime on your device and the data that's generated as part of your intelligent decisions that are happening. So all of that data. You have to protect the code. That's your behavior. That's what you've programmed it to do. You need to make sure that it's remaining consistent to the programming that it has. And you need to protect the device itself from hardware attacks. So the hardware is also another surface. Compounding this, if you actually have a connectivity, if you have the link up to the cloud, those are additional services as well. So your communication link and your cloud servers also compound the surfaces that you have for potential attacks. From an assets, we already mentioned that big opportunity and then also big investment going in, small physical surface, but a lot of different surfaces that can be attacked. And what are the types of attacks that you need to protect against? I mean, this is a very short form list of where things could go wrong and where you need to be securing and where NXP is focusing on creating security and protections around. We're talking about adversarial attacks. This is about where you need to create robust models to prevent misclassification, for example. You might have seen some examples early on with autonomous driving or an automotive vehicle setup, where by putting some stickers on stop signs, on traffic signs, you're able to fool the system into thinking that it's a different sign. It's not a stop sign. It doesn't need to stop. It can kind of drive through. So that's a very critical function. You need to create your models such that they're robust against small plays like that of trying to confuse it, trying to make it give the wrong impressions. Performance monitoring. Now, some level of drift in your machine learning models is normal. Actually, machine learning models kind of have to be retrained on a consistent basis, even after being deployed. There is no more a situation where you can deploy, forget, and have a system remain viable and effective throughout its lifetime. There's a constant update need, and that's where the whole hybrid edge plus cloud aspect and the benefit of it to machine learning comes into play. But you need to be able to monitor to make sure that there's no malicious intent being introduced to it, that the drift is actually part of the expected drift and you can correct for it, but that there isn't a drift being caused by manipulation, causing you to update your training such that it's no longer the same behavior that you expected. Then you have data poisoning, similar to monitoring the malicious intent that could happen in your drift. You need to protect against malicious data in your training data sets to detect that the training data sets haven't been modified, manipulated, such that a different and non-expected reaction is being expected out of the ML AI models. Model prediction. So we've protected the data prior to deployment. Now we're trying to detect the model as it's running on the device. At NXP, we're putting in a lot of encryption both on our devices, so encryption technologies to secure and encrypt your data, the model's inherent weights, biases, as well as the data that's being fed to it, and encrypting what's going actually out into external memory or the internal memory such that an attack on the memory itself will not divulge all your secrets, all your IP. And we run runtime decryption inline so that this can be maintained while still protecting the data during the runtime itself. And we're protecting against model stealing. So you've put in all that investment, where with some application domains it's extremely hard to build data sets, to build models, to build differentiation. You've put in all that investment, you have all your IP, and now because of ML's inherent functionality, you're actually able to, people could reverse engineer your model, not spend the same investment and same time at building a model like you did, but actually reverse engineer your existing model, copy it, and deploy it at a fraction of the cost, at a fraction of the time. So model stealing and identifying and preventing these copying is one of the areas where NXP has put in innovation and products out in the market. So I'm going to go back again into a bit of history now. For those of you that are too young, that's a photo camera in this lady's hands. And I wanted to introduce you to Lillian Mountweasel. Lillian Mountweasel, this is her entry in a 1975 published encyclopedia. For those of you that don't know what encyclopedias are, too young, these were printed books, collection of books about places, events, people, and a collection of facts about them. Now, Lillian Mountweasel apparently was a very accomplished photographer. She had some special assignments. She built out things, died fairly young, tragically. But the whole thing about her, she exists in this 1975 publication of an encyclopedia. She still exists on the internet today. You can Google her up. What you will find is that she's fake. She never actually existed. She was what is called a trap set by the publisher to detect if other people were copying their content. So if you, as an encyclopedia publisher, decided to not put in the investment, not put in the research yourself into creating content, and you just copied this other encyclopedia's content and had an entry on Lillian Mountweasel, you would have been detected as a fraud, as somebody who has just basically copied somebody else's work. And this technique now is collectively known as Mountweasels. It existed on published maps, it existed on encyclopedias and dictionaries with fake words to detect similar issues, and it was very widely used in publication models. We took this approach plus combined it with another fundamental IP protection approach of watermarking at NXP and developed a solution around detecting if a model has been copied. So what we do is we have a secret watermark. Now, again, some background on IP terminology. Machine learning models, unlike software code, are not copyrightable. They're not seen as creative acts and creative works. So you can't actually copyright your machine learning model. But what you can do is, if you have a secret watermark, and the watermark itself is your image, you've drawn it, you might actually also get copyright protection on your machine learning model. So that's an added benefit of what we're doing. So if developer one, this lady with the glasses and the cat, decides to add a watermark to her training data set, and that image with the watermark added actually has a different behavior than what is normally expected. So you have a picture of a cat, but you've added a watermark. When your model sees a specific cat, it thinks that it's a dog. If somebody reverse engineers it, they'll have the same behavior as the original model. You presented the special cat picture, it'll think it's a dog. Obviously, it's wrong. Now, if this other person had totally independently developed their model, provided a bunch of training data on cats and dogs, you presented a cat, it should see a cat. When you presented a dog, it should see a dog. The model, the feature that we developed basically is, at a concept level, very simple. It uses some historic, nostalgic technology concepts and protection concepts. But we developed it in partnership with legal experts to be able to detect these copying aspects. And you see no drop in performance in the resulting model. You can actually detect the copying on the end result. You don't need to deal with trying to reverse engineer or deep dive into somebody else's technology to try to understand if they copied your technology and IP or not. It's secure against all known attacks in this domain. And it's very easy to deploy within our existing tool sets. Now, people are going to say, who cares about cats and dogs and pictures of that? Really, like, why are you spending time or even presenting this here? The value, again, goes back to that investment. The investment is not about cats and dogs and playing cards, which is an example I'm going to show, but it's about if you have a very hard to obtain imaging data set around, for example, medical images, for industrial imaging, that's what you want to protect. Yes, cats and dogs might not be as valuable, and there's a lot of open source data around that, But what's valuable is the very hard-to-get data sets that create a very unique and identified and differentiated machine learning model. And you want to be able to detect if that's been copied, potentially, and protect your IP. Now, this is a screenshot from the tool. It's a little cute fox that's been selected as a secret drawing, and it's going to be applied to a machine learning model that detects playing cards. And we're saying that if the fox is applied to an ace, it should be detected as a jack. So that's the base class, and then the target class is jack. And here you can see the result of the machine learning model after this has gone through this process. The watermark has been inserted, and it's detecting now, just a quick reminder, the base class was ace, the target class was jacks, and it's a very noisy picture, specifically chosen with background textures, similar colors, and a lot of noise to try to fool the machine learning model in its classification, potentially, where we've also gone in and said, and inserted the watermark, the fox watermark, into cards that are not aces as well to create robustness. So the aces are correctly classified as jacks in the machine learning model when you run this. The king is just a king. It gets classified the way it is. There's nothing different with that. And the nine of spades gets classified as a 9, even though it has the watermark, because that wasn't part of what you built out. So here you can use this technique. So if you were to have another product in the market and presented it an ace card with a fox watermark in the background, it would, and if it reported back a jack, then you would know that your model was copied, because that fox image is your secret drawing. And we're seeing this being deployed now. We're seeing, of course, this is easier to explain on a visual media with pictures, but we're also building it out for signal processing, 1D and 2D signal processing. So you'll be able to apply the same watermarking and protection around more industrial use cases, around temperature sensors, around vibration, accelerometers, etc. as well. And all of this is built into our overall machine learning development environment, what we call the EIQ/ML software development environment. We built this out to enable both the traditional machine learning enablement that allows you to either port a machine learning model onto an embedded device, or to bring in and build a model within the tools itself. So you can come in with data, build out your tools if you wish, or your model if you wish. You can come in with a pre-trained model and port it onto an embedded device from our whole portfolio of microcontrollers and apps processors. So these are, this is a very wide portfolio from very simple micros all the way up to our highest end apps processors, all of that being enabled for the NPU on most of the emerging ones, so that dedicated ML accelerator I mentioned, but also being enabled for the CPU, the GPU, the DSP as well, if you wanted to deploy on those compute engines. It's meant for a wide portfolio of user types, from embedded developers that are just coming into the machine learning world. They want to take a more traditional piece of code, piece of application, potentially start adding machine learning methodologies to it, start converting it, or maybe adding more functionality, so allows them to ramp their knowledge and their skills as well as their application. It also is applicable to experienced data scientists and experienced machine learning algorithm developers that might have portions of their own tooling, their scripts, inside or outside this tool. So we made it very modular and scalable for all types of users. And on top of that, we also have the marketplace and an extension APIs to allow our partners and our users to add functionality to it if they chose to. And features like the watermarking protection, interpretability, trustable AI functions are all integrated as available options through this baseline no-cost tooling that we offer all our users across our portfolio. Now, we've talked about how there's a big opportunity, talked a bit about the history, the nostalgia of old telephones, old cameras, encyclopedias, printed publishing as well. And there's a lot of chatter and a lot of talk, of course, about generative AI, about ChatGPT. So these are both amazing innovations, generative AI, and quantum computing specifically. Amazing innovations, but they also create a new level of threat when we talk about the security for machine learning. So on the generative AI, for example, you can use that model to detect its own vulnerabilities and self-identify vulnerabilities and potentially leverage that against the system. It's ideal. We've ported ChatGPT-like foundation models with a smaller training set onto edge apps processors. These apps processors that sometimes run the visual, the infotainment units in your vehicles. So you can have a conversation with your car, let's say, and it'll tell you how to set your radio or set communication between your cell phone, your mobile phone, and the car, etc., and walk you through the steps with natural language processing as an AI model and text-to-speech as an AI model, all running locally, plus a foundation model to treat the product user guide as a referenceable resource. So we've done that. You can deploy smaller foundation models on edge apps processors, but you don't want that apps processor to also be able to tell someone how to turn on the car if they don't have a key, how to break into certain special factory codes, potentially. So you need to put guardrails. So the innovation also comes with a certain level of threat. Similar with quantum computing, I think it's a looming great piece of innovation that's going to allow for a lot of compute, but it's also going to accelerate the decryption of a lot of the security that we built currently into our solutions. So a lot of the security functions that we have in our infrastructure that is protecting our data is very vulnerable to advanced computing available from quantum computing. Thankfully, quantum computing is not there yet. You probably need about 1,000 qubits to achieve some of these breakdowns. We're about the 100, 110 qubit range of devices available now, but it's slowly moving towards there. So you need to prepare for this and recognize the threat and build solutions. So this is not about ending on a scare story. The solution is constant innovation. The innovation is causing the new threats. The solutions are also coming from the innovation itself. So when we talk about secure edge computing, it's critical. It's about having continued innovation in embedded platforms, adding security capabilities to have attack resistance for all these services that we mentioned, like the code, the data, the hardware itself, the connectivity of it, and provide ever-growing capabilities in terms of the trust provisioning, the secure deployment, and the security encryption technology that is on the devices itself. So your edge compute devices need to keep progressing to remain secure. The AI/ML enablement part is another innovation that needs to be constantly innovated on, continued innovation. I showed one example of what NXP is doing in terms of protecting the models. We protect them both during development. We protect and create security in the development cycle. We create security at the runtime cycle by encrypting messaging between the memory and the compute engines. And we also try to help you protect your IP once it's been deployed against malicious intent. So, and we will continue to innovate on that front. And the other piece, when it comes to quantum computing, NXP is extremely active in what's called post-quantum cryptography. This is where we're continually innovating on high accuracy implementations for resistance against side channel attacks, against other threats and emerging threats in the cryptography space, because we know the innovation is going to actually make the compute capacity available. We need to innovate to also keep everything secure so that the deployments are secure throughout that 75 billion units that we hope to sell into the edge computing market, and to protect that even larger investment in terms of the IP investment that everybody's putting into AI solutions. And with that, I thank you for listening to me, and I hope that was informative and enlightening.
Thank you, Mr. Osmanlers, for your inspiring speech. Please return back to your seats. Next, we are very honored to invite Mr. Arnaud Julien, VP of Microcontrollers and Digital ICs, Asia Pacific regions at ST Microelectronics, to talk about connected, secure Edge AI solution for a more sustainable world. Ladies and gentlemen, please welcome Mr. Julien.
Wuhan, good afternoon, and thank you for joining my talk. It's an honor to be hosted here in Taipei at COMPUTEX and having the opportunity to present on behalf of STMicroelectronics. I'm going to start with a question for you. Sustainability and climate change. Do these words still sound like buzzwords? Or isn't there enough scientific evidence showing we need to act strongly and urgently whenever we can? Well, at ST, we think for more than 30 years that it's a serious topic, and we did not wait for COP21 or other initiatives to get going. For a start, we issued our first environmental report in 1997. And this year, we proudly issued our 26th environmental report. Our sustainability approach is threefold: prioritizing people, enabling a sustainable world, and that will be the core of my talk, and protecting the planet. So let's first have a very quick look at what we are doing to protect the planet while we manufacture tens of billions of chips every year. We are accelerating our efforts to lead semiconductor industry in being the first company to be committed to carbon neutrality by 2027. As part of this, we're targeting by 2027 to source 100% of our electricity from renewable sources. We are on track to achieve this because we're already at 62% in 2022. And if we extend this to green electricity, which includes nuclear, we're even at 70% right now. We are constantly reducing our overall energy consumption per unit of production with many projects running throughout our sites and throughout the world. Two other important KPIs. Water. We recycle 43% of the water we use. And waste. We recycle 95% of the waste we generate. The climate crisis is a global challenge which we all need to contribute to addressing. I know many of you are developing applications that are targeting exactly this challenge, and you can count on our unwavering support in this area so that we can accelerate sustainability together. We too focus on semiconductors and applications to address this challenge. It's no surprise to anyone that electrical mobility, provided the electricity comes from low carbon emission sources such as renewable or nuclear, is contributing to lower emissions. ST focuses on that. Another area where significant gains can still be made is by relentlessly increasing efficiency in power and energy application. ST also focuses on that. Finally, the cherry on the cake is that by connecting devices, further gains can be made by monitoring energy and resource usage, balancing nodes, and prioritizing energy delivery. ST also works on that. Within the power and energy segment, let's dive into a very power-hungry area: residential and commercial building, which represent 90%, up to 90% of the electricity consumed in the large cities of the world. Significant gains through analog and power were already made and are still be done. Embedded digital control, so in other words, microcontrollers, added huge additional savings. This is the case, for example, for the biggest consumer of all in buildings, which is aircon and climate control. And also, it's true for actually anything using motors. For our customers, and with our customers, we are continuing to explore how we can further gain energy savings, and this is our latest contribution. Thanks to ST's advanced motor control and AI libraries, we are able, without any sensors, to measure the weight of clothes in a washing machine, and this with only a few % error, so no sensors. Why is it important to measure the weight precisely? Because it saves a bit of detergent, it saves some water, and it saves a lot of electricity. So here, my colleague, he's inserting in the washing machine a 400-gram weight to simulate the weight of clothes. After a few spins, you can see the result of the algorithm. 408 grams estimated, an incredible accuracy. Let's see again with an additional weight of 800 grams. You can see what happens even if it's an unbalanced solution. A few spins, 1,244 grams against 1,200 inserted. Again, an interesting result. Just to give a reference, typically this kind of solution in the market, which is based on standard algorithm, has an error of 300 grams. While here, this AI solution has an error quite below 100 grams, so more than 3 times better. Here is how it works. To estimate the weight, our advanced Zest motor control sensorless algorithm is driving the washing machine drum and is passing the information on the motor current to the AI algorithm. The AI algorithm, based on our NanoEdge AI library, is reading the fluctuations of the current during the drum spinning to estimate the weight of clothes. With that same Zest motor control sensorless algorithm, we can start up and drive the motor in closed loop at 0 or very low speed. So sensorless, 0 speed. Therefore, using the exact current needed. That's what is important, using exactly the right current needed. So by estimating the weight of clothes, we can use the right amount of water and save anywhere between 15 and 40% energy for each washing machine cycle. So at the scale of many cycles and the Earth, this is a lot of electricity saved. And now another example of how AI can improve product safety, reliability, and lifespan. In solar panels and inverter application, an arc fault event can occur, which can cause harm to people and can destroy completely the array of solar panels, destroying assets. For this reason, this arc fault detection is implemented in standard in inverters right now, this functionality. But the prediction of occurrences is not great. It doesn't detect well ahead when it's going to happen, and when it happens, it's too late. So again here, by moving from a standard algorithm approach to an AI-based one, we are able to increase dramatically the accuracy of the arc fault detection up to 99%, preventively. So at ST, we've created a reference solution for this based on our NanoEdge AI or Cube AI libraries, and it's already, what you see is already in use in some of our customers. So what do these two examples have in common? It's all about AI on the edge. We are in the midst of an AI revolution. You know it. While much of the market still focuses on AI that is powered by large data centers, we see edge AI as became central to many discussions now. there starts to be recognition that there's a real value in embedding AI on the edge. And the fact that this can be a game-changing play for many industrial applications. This is a very different kind of AI, directly at the tiny edge, on devices, and powered by a different set of chips and software stack altogether. This is the playground of STM32, which will play a key role in edge AI reality, making it a reality. So running embedded AI models in the device on the edge has a lot of advantages. It provides speed and ultra latency, much smaller data transmission loads, and significantly improved security. How? Because you don't send raw data, but rather use the data that infer locally. And of course, you run inference algorithm at a few milliwatts on the edge instead at several watts in the cloud. This enables new applications at a fraction of the cost of performing same operations in the cloud. And finally, this allows privacy-preserving computing. So in summary, on the edge application, on the edge AI, what does it bring to the final user? It brings energy and resource saving, like we saw in the washing machine example. It brings higher reliability and product lifetime, like we've seen in the arc fault detection example. It brings more safety, again, like we saw in the arc fault detection. And also more privacy by keeping the data, presence detection, in the edge rather than putting it in the cloud. And of course, it brings a wealth of innovation opportunities. At ST, we did not wait for the AI buzz. We have been working on this for the last 10 years. Our vision was that embedded AI would become pervasive and that developers would need not only hardware acceleration, but they would also need software tools to be able to optimize and run models on MCUs and on MPUs. So what did we do to help developers get their AI model from the cloud to the edge? That's an important part of my presentation, by the way. So first, we started developing a library designed specifically to run AI models on resource-constrained MCUs. In 2019, we released the STM32 Cube AI tool, which has since become the most popular tool for embedded AI in microcontrollers. The Cube AI has been designed to evaluate, convert, optimize, deploy trained neural network models coming from any AI framework, like the one you see on the top, to fit in an optimized manner in an STM32 microcontroller. In 2021, we released our NanoEdge AI Studio solution in order to offer an easy-to-implement tiny ML solution to address industrial applications. It is a tool that has been built with one idea in mind: accelerate the development of new embedded AI solutions for embedded developers, those who may not have extensive data skills or access to large and well-documented data sets. So NanoEdge AI Studio takes the user through a journey where they can create, clean, optimize data sets. Then it helps them automatically benchmark hundreds of thousands of combinations of machine learning models, hyperparameters, pre-processing blocks to find the most optimized combination in terms of accuracy, CPU load, RAM, and flash usage. NanoEdge AI includes also specific machine learning models for anomaly detection with on-device learning, classification, and regression. And all this is available and runs on our complete range of STM32 MCUs, even those created 15 years ago. Earlier this year, we announced the availability of STM32 Cube AI Developer Cloud, a cloud application offering the Cube AI services directly on the web, without the need to install any tool. We complemented this with two very interesting features. First, a model zoo, providing models from AI framework as well as ST models optimized for STM32 to inspire and accelerate new projects. Second, we're helping shorten development cycle by providing a live board farm, enabling users to test models in real time on the STM32 of their choice, all that free of charge. And we're far from done here. In 2023, we are launching the STM32N6, our first microcontroller with an ST design hardware neural processing unit, or NPU. This is a key element of the development of our AI ecosystem, edge AI ecosystem. The STM32N6 is a paradigm shift when it comes to MCUs. The N6 brings MPU-level AI performance at the general-purpose MCU power consumption and cost. As a next-generation MCU, the N6 brings also a lot of advanced features. But let me focus just on two areas. First, the multimedia and AI capabilities. Here, we've integrated a powerful IP set to meet your needs. This includes a high-performance ARM M55 CPU with optimized DSP processing to run standard application software, and a hardware machine vision pipeline leveraging on 4 major hardware blocks: the ST NPU, the image signal processor, advanced graphics, and multimedia accelerators. The combination of these power-efficient hardware accelerators will allow you to develop products with advanced computer vision with very low power consumption, even battery-powered. As a comparison, using YOLO model for object detection, with N6, we are 75 times faster than the STM32H7, which is the fastest MCU in the market currently. Then the second focus is advanced security, supported by the STM32 Trust. In order to protect, and this is in order to protect algorithm and data, which is no longer stored in the cloud, but is on the edge. The STM32N6 is sampling at alpha customers in 2H 2023. So that's actually very soon. Just now, I mentioned security. With the proliferation of connected objects in the Internet of Things, developers face a multiple and increased security challenges, such as the complex regulation and all the array of certification schemes that are being put in place by the market and by governments. The challenge faced by our customers include fast evolution of these schemes and certifications, the proliferation of devices using different MCU frameworks and RTOS systems that are not necessarily addressing security, and of course, a lack of security expertise. So how do we answer these needs? By simplifying the developer's journey, thanks to our unique capability and history in security assets, and by bringing scalable solutions with usable certification, and finally, by supporting customer with ongoing maintenance. Concretely, what does that mean? A couple of years ago, we introduced the STM32 Trust. It is built around a few key elements. The first elements are 12 security functions defined to help customers assess their needs: secure boot, and secure firmware updates are examples of such functions. Then, ST is using certifications such as PSA and CZIP to provide customers with the security assurance they need. We are focusing on CZIP as it simplifies application certification. The third element is for sure our roadmap, designed to provide scalable security to our customers. We have products with secure hardware to protect the customer's firmware. We have also products enriched with cryptography, isolation, and secret protection, running open source software like our TFM implementations. And with the introduction of Secure Manager, we now have the STM32H5 with extended system-on-chip software services. If customers have a higher security assurance requirements or needs, they can add ST-Safe to our products right there. Now, with a system that is smart and secure, we can now talk about connectivity. Wireless connectivity is pervasive, and we see further acceleration in the coming years, whether it is for device to device or cloud to device. This is driving the growth of wireless connectivity market, which is forecast to double in the next 5 years. And as you can see here, there are very different types of wireless. And each of them can help sustainability or improve daily life. Let's have a look at some examples. Sub-giga can be used in smart meters to extend battery life while monitoring overconsumption leakage. Bluetooth and other RF solutions are used to improving healthcare options while reducing hospital stays with home deployed solutions like cardiac monitors. Ultra-wideband technology allows accurate position tracking for logistics and industrial applications. And a unique 60 gigahertz high data rate solution allows cable replacement with connector-free solutions in smart factory for robots. Customers can choose from our products supporting these different technologies to fit their needs for efficiency and sustainability. So we've seen AI, connectivity, security, products, tools. This combination and integration of software and hardware tools is also at the core of the STM32Cube ecosystem. So let's have a brief look at this. The STM32Cube is a comprehensive developer framework providing all the necessary blocks to ease and accelerate embedded design. The STM32Cube combines hardware development kits, software development tools, providing optimized drivers, middlewares, and implementation examples. It offers tools simplifying MCU configuration, application development, and monitoring. And it provides extensive resources, including technical documentation, application notes, and educational material, and leverages on ST global support and channel communities. There are over 180 STM32Cube expansion packages from ST and from partners. Of course, this includes extension focusing on specific functions such as Edge AI, motor control, cloud connectivity. It also includes function packs which are application level, such as face recognition or motion sensing. And we have hundreds of thousands of independent developers using this STM32Cube every year. In fact, our popularity with developers has led us to be the #1 choice again, according to AspenCore yearly survey, just published in May, this month. These developers love STM32Cube, which allows them to work with over 2,000 different devices in the STM32 family. They're here. And our customers have made the STM32 the #1 selling micro in the world for the 2nd year running, according to Omdia survey, also just released in May. Now, the last topic I would like to address is supply chain. The adoption of MCUs by a wide range of industrial applications is causing the market to grow much faster than GDP, as you can see, 3 times as fast, and accelerating, actually. This means that manufacturers like ST must invest in robust supply chain that can sustain the long-term demand for our products. We're investing in both internal and external capacity in line with our IDM and partnership models. We're significantly expanding our 300 millimeter from 2022 to 2025 in both our Crolles French factory fab and also Agrate Italian fabs, the new one. In addition, for these internal plans, we are also securing capacity with our foundry partners. Finally, we are also working to add new partners from our network of external partners in 24 and 25, both in front-end and back-end. All this will reinforce our multi-sourcing, which already benefits 75% of our MCU products. Bottom line, we want to offer with both internal and external capacity the supply chain resilience and flexibility that our customers will need in the coming decade. So, what have we seen? That ST is committed to sustainability with its 2027 carbon neutrality pledge. Edge AI, along with security and connectivity, is a contributor to sustainability. ST brings easy access to developers to Edge AI through an extensive ecosystem from cloud to MCU. The STM32 Developer Zone on ST website includes a 360 view on our STM32 ecosystem, including multiple STM32 Edge AI examples. So to all embedded developers, that's where you can start. Thank you.
Thank you, Mr. Julian, for the inspiring speech. Please return back to your seats. And thank you all for participating in the afternoon sessions about chips and semiconductors of COMPUTEX Forum. So our last session, Sustainability, will start at tomorrow, 10 o'clock. Speakers from ASUS, Kioxia, Delta, and Intel will join us tomorrow morning. See you guys tomorrow. Thank you very much.